let Sarah explaining you in detail. I know that you can't wait for this. I can see this in the chat, so I will let Sarah explaining the summer training.
Yeah, just okay. I'm just checking the chat. Okay, so we are going to start with the ready for summer's training. So we will keep this this experience for summer. I mean summer in Europe. I know that some of you are in Australia, so it's not summer, but you know what I mean. And the idea is to characterize the light curves of Kilonova candidates. And so maybe you don't see the link with gravitational waves, but remember that when you have a gravitational wave event, you don't know where is the source, right? You have a very wide localization and error. And so we practiced, remember, last year now, to point and to observe some galaxies. And then the step was, okay, I observe my galaxy and maybe I find a candidate that is nearby this galaxy and can be the kilonova. But after this first step, you need to be sure that it is a kilonova. And so since the sky is so noisy, you can finally find a new source, but it's not a kilonova, and maybe it's a supernova. So the second step of gravitational wave follow-up is to observe the candidate to understand if there is or not kilonova. And so with that training that we do, we do the second step of the gravitational wave follow-up. So our idea is to use a survey, and we will come back to that just after. A survey, which means a telescope with a very large field of view of 20 degrees square, maybe. No, 20 by 20, I think. So, no, 20 degrees square. Well, and this survey is doing routine observation every night, and so it detects some new sources that might be early supernova, that can be variable star, it can be anything. And so more and more you have data, more and more you can classify them, and more you are sure or not whether it is a kilonova or something else. So since in Grandma we are very interested about the early observation, when the source looks so new, we don't know at the present time when we send the alert if it is sure that it is a kilonova or it is not, probably like maybe 10% that's the kilonova or not. So here we are going to play the game to look at some candidates that can be reasonably kilonova, but maybe after 1 day, or maybe after 6 hours, or maybe after 3 days, or maybe after 10 days, maybe they won't be kilonova, okay? So the game that we propose for you is to observe in order to help to determine whether or not it is a kilonova. So this campaign has been elaborated with the help of our Grandma colleagues, so Michael from University of Minnesota and Cosmic Taki, who is from Observatoire de la Côte d'Azur, and Sergei, who is from FSU in Czech Republic, and also with another collaboration that is not Grandma, another collaboration that is FINK, that in fact is in charge of looking at all the new sources detected by this survey and try to put a score on this so sources to determine whether or not in real time if it is with the data that we have, if it can be a kilonova or not. And so our duty will be to enrich this data set in order to help the score given by FINK. And so FINK team, FINK is a French project, but there are many projects, maybe not many, but 10 projects similar to that all over the world. But here we are based on the FINK on the front project that is named FINK, and it is led by Julien, Émilie Ishida, and Anaïs Moller. So Julien is at IJC Labs on Yorkshire, and Anaïs and Émilie are at LPC Clermont-Ferrand. And we have an amazing, maybe she's here tonight, student that is really pushing the work, and from Institut d'Optique, and she is one of our interns that I talk about. Okay, so maybe I can take the minutes so that Michael can present the optical survey, because he is from these telescopes. Michael, you want to present the slide? This is your slide.
Okay, so as Sarah mentioned, there's a variety of optical surveys around the world. And I think many of you have likely heard of LSST, which is now known as the Vera Rubin Observatory, which is a wide field optical telescope, kind of 8-meter class that's being built down in Chile currently. And here in the US is kind of a predecessor of LSST, which will be online in the next couple of years. We have this system that's called the Zwicky Transient Facility. And so this is a survey that's on a 1.2 meter telescope, so much smaller than LSST will be at Palomar. But what makes it kind of exceptional is the 50 square degree field of view. So, most, let's say, me and or amateur astronomers kind of have narrow field of view telescopes. You can kind of do some handful of arc minutes, but ZTF is really designed for finding transients. And so the idea of ZTF is that you observe the same piece of sky every couple of nights. And so combined with its wide field of view and its sort of these repeated observations, it's really excellent for putting out what we call alerts, which are just basically objects that are identified as being variable in some way. And so ZTF has been running for a couple of years, and it is funded for a handful more years. And it's this survey that we'll be using for our, let's say, test bed for our summer training session.
Yeah, and so I apologize, so the field of view is 44 degrees squared. And yeah, so look at the number of alerts is very big. And so the FINK project is really to classify this alert to redirect to some different programs. And so our program is Kilonova 1. And Michael, can you say some words, maybe where is located ZTF and maybe LSST?
Yeah, that's right. So ZTF is on Palomar Mountain, which is a couple hours south of LA here in the United States. And yeah, so it's on this 1.2 meter telescope. LSST is going to be on Cerro Pachón, which is outside of La Serena, Chile. It's let's say on the same mountain as a variety of other systems that you've likely heard of, things like the Blanco telescope, which has the dark energy camera, the SOAR telescope, and others. And so it's they're complementary in some sense, because the ZTF is a survey predominantly for the northern sky that goes down to something like -30 in declination, and LSST again is in the south, and therefore it'll go to something like +30. So they have some amount of overlap, but definitely cover, let's say, different regions.
Okay, thank you. I just tried to look if there is something present tonight, but I don't see them. All right, so let me present their project for them. So FINK, as I said, it's a project that tries to classify all the candidates, and so they use first ZTF, as said Michael, and ZTF is running to be ready for LSST. That will be, I think Michael, you said, the observation will be really start in 2022 or even 2023 now. Okay, so you have, so I think is listening to all the trigger of ZTF and then it tried to filter and to classify them. For example, here in the FINK platform that in fact we will use, okay? And I will come back to that later. You know, they say, okay, so ZTF na sources, because it's a source is detected by ZTF, right? And so they said, FINK classify as SN candidate, for example, and then they give some location and so on, etc. And so they are very prompt because they try to classify. So most of the alert that are, for example, finally they found that it's a source that is found in catalogs, or it is something related to the solar system, or supernova, or etc. Bon, we did not yet, just to be clear, we did not yet find Kilonova with FINK or ZTF yet. Otherwise, I would have started with that. So maybe it is us that will find the first candidate, first Kilonova with ZTF. You know, who knows? Okay, so imagine that we will send this kind of alert, right, under the Slack. And so when you will click on maybe let me come back to that, and I will come back to the other one. Okay, so the idea is that we are going to listen to this FINK Kilonova alert stream, and every Friday, so just for the moment, we start very slowly, okay? So every Friday, we will send you the candidates that are found during ZTF night. So since ZTF is located in USA, so during his night is from 2 UTC, I take margin, 2 UTC to 13 UTC. And so ZTF, I think, is immediately, so it scans the sky, and when it finds a trigger, it's immediately transmitted to FINK, then categorize sources, and then transmitted to Grandma. So which means that we have we have maybe 5 minutes latency between the data has been taken and then classified, and that it is delivered to you. So it's very very rapid. So that's why you can have received some alerts at early nights of ZTF, okay? And so when you have, ZTF you're observing, and then FINK is classified this image, and to try to enrich or not the classifier. And if the classifier shows that it passes threshold of being a Kilonova candidate, then it is redirected to us. So there are two criteria that it is whether a Kilonova or not. I mean, there are two criteria of filters, right? There is one that is in the channel FINK Kilonova-like curve, and there is another criteria that can indicate that it is a Kilonova, and the alert will be redirected in FINK Kilonova mangrove. So in fact, they have different, they pass different thresholds. I hope that I did not last you. So the first filters is mostly based on the light curve. So we just check on the light curve and we say, okay, it can be look like a Kilonova light curve. But remember that we have seen only one clear light curve with gravitational waves. So it's very subjective to have a light curve, which means that you have already a lot of points. However, it is very interesting. So usually with that first approach, you need, at least 2 or 3 points. So the transient is already old or getting old, but at least it is very interesting, because if it is not a Kilonova and maybe classify later on as a supernova, it must be a true sources. So it's good for the science. So you have this first filter. The second filter is very different. The second filter tries to catch the early light of the kilonova. So you just need 1 point. So you cannot make a like curve with my 1 point, right? So the idea of the second filters is much more like risky. It just like try to look at if the point that has been just detected is very close to a nearby galaxy. And it computes the absolute magnitude of this transient close to the nearby galaxy and check if it can be conceivable, if it is as bright or as not bright as the kilonova. So you have the first criteria that is conservative, you know, and the first one that is more liberal. And so that's why we try to test the two approach. I would like to say that for the moment, there is no citizen science program that do this kind of things. So you will be the first one of the first one. But there are some follow-up of the ZTF candidates that are done by professional or maybe some individual, but not as a group. So this is really, really new. So apologize if we are experiments, but I think it is the great things of the science to experiment. Okay, so you will receive in 2 channels the candidates that pass the 2 thresholds during the Friday, so in the night from Thursday to Friday, right? And then we invite you to follow this candidate, and you will have 3 days, up to 3 days to observe them. Because the idea, remember, is also to be trained for. So we try to adapt the same methods as O4 for gravitational. So you just go to this Slack channel, and then you can click on the link, and you will have exactly this. This kind of you will be redirected to the FINK web portal. Then you will have the name of the candidate. You will see that it is classified for the moment, okay, as Kilonova candidate. You will have the date of the discovery. So it is different than GW, because in GW, when you have the GW alert, you know that the collision happened. Here you don't have the collision time, let's say. So maybe ZTF have observed this point, but maybe the hypothesized gravitational wave were done very earlier, right? So it's just a discovery of the new source. It's not the merger time, okay? And so here you have the localization, and you have where it is the magnitude somewhere. Okay, can someone help me? I don't see them. All right. Well, and here you have the start of the light curve, and you will see that where?
There is a button to change between magnitude difference and magnitude in the blue frame.
Ah, ok, c'est bon. Ok, merci. Okay, so this is the thing that you can have a look. I hope it is not too geek, but I hope it is clear. Okay, so as I said, you will receive the alerts into your channel, and so to show this portal, you will have that message, right? So you will click on that, and then you will obtain that. Sorry, my slides are not in the right order. So to simplify the things, we have sent you a summary of the FINK portal page. So this is what you will get on Slack. So you will have the same information, and you will have the actual scores that can be updated within hours, within days, okay? And you will have, and here it is clear that you will have the upper magnitude to decide whether or not you have the capacity to observe with your actual telescopes. So Damien, did I forget something? I don't think so. Is it clear for the moment?
I don't think so. It's a lot of information, of course, for all of you, probably, yes, but I think you did the right things, Sarah. So, but anyway, feel free to ask any question, and even after this meeting, don't hesitate to send us some mails if something is weird for you or unclear. I'm trying to answer to all of the questions in the chat or in the Google Doc. So if there are things unclear, don't hesitate to post.
Okay, so you have this, it will pop up on Slack. You will have this message once again, and you have the Kilonova score. It passes the threshold because it is 0.86, right? So the score is from 0 to 1. So pass the score. You have the other score around, and you see that, for example, for this candidate, supernova type 1a is 0.5. So it doesn't mean because you have a high Kilonova score that the other score, it is not compatible with other sources. And what I would like to pay your attention in this TNS link, I don't know if you know TNS, but it is where people, professional, I think mostly professionals, they report their observation. Because FINK, the particularity of FINK that is only deals with ETF information, but us as GROMA and Kilonova-catcher participants, we can enrich this information, and this is the goal of the campaign, and then we see that maybe it does not fit the Kilonova-like curve. So I invite also some of you to also look regularly at the TNS link to see if they have updated further information, and maybe it won't be anymore. Surely, it will be surely not Kilonova. So to be clear, we have made a roadmap or recommendation for different cases. Maybe Damien, you can explain that, because you make the slide. Well, I can make it.
Sorry, I was on another thing on the Google Doc. So you want me to explain the format of these alert messages?
Yeah. Yeah.
Yes. No, so right. This is. Yes. Okay. Oh, sorry. The screen was frozen for me. Okay. Yes. So. Yes. Sorry. So yes. So. There are different cases for all of you guys, depending of your telescope or capabilities, and depending also if you have a telescope available now for the training. So these are raw cases. I mean, there are probably other kind of cases we can think about, but I think the first case we can think about for taking some follow-up images of those Kilonova candidates provided by FINK and GROMA is the case where your telescope is probably sensitive enough. So as you could see, we provide an apparent magnitude for the source. So for the Kilonova candidates, so typically between 17 and 18, sorry, maybe up to 15. We can go down to 15. And so if you think that your telescope is probably sensitive enough to observe this kind of objects, so and if you have color filters, like typically bluish filters and reddish filters, it's would be great to take successive B, like blue, and R, so red images for the Kilonova candidates. It's really important because for Kilonova candidates, you can have big differences between the blue bands and the red bands. So in terms of flux evolution. So that's why we usually ask for blue and red observation for this kind of candidates. What would be great is to, as Sarah said, is to continuously take images for 3 days after you receive the alert on Slack. What would be great also is to take it as deep exposure as you can to reach enough sensitivity. Well, you can pause for typically several minutes, for example. Of course, we will make some try. I mean, the first alert, we will make some try. We will see your images, and we could improve the advice the advice we could give you later for the next alerts. But what is also very important, so take color images if it's possible for you, and also take several images per night at different periods of the night if you can, of course. The interesting thing is to have some intervals between 2 periods of observation of maybe 1 hour if you can, 2 hours also if you can. But if you can't, if it's only 30 minutes for you, you can make only different shots in 30 minutes interval. It's still okay. But this is just to say that if we want to measure the flux evolution, etc., of the transient, it is always better to have several images, even within the same night, even if the transient is a bit slowly evolving during the night. But within several nights, we will collect enough data to see the flux evolution of the transient. Case number 2, well, you think your telescope is also sensitive enough to detect this kind of transient candidate, kilonova candidate we will send to you, but you don't have any filter. So you have typically, I don't know, a luminance filter or very broad filters or things like that. Well, same thing as the case 1, just take successive images, unfiltered images, and for 3 days as deep as you can, and several images per night would be great within the periods of let's say hour time scale, something like that. The case number 3 is well, let's say my telescope is probably not sensitive enough for observing for detecting the candidate. Well, what you can see is you can still try to take, of course, filtered or unfiltered images with as deep exposure as you can. If you know how to do this, you can try to perform image stacking. If you know how to do it, for example, this is something we can discuss all together, how to make a good image stacking to improve the sensitivity of your images you stack. So you can try to do this, for example. I think if you think your telescope is really not suitable for faint, let's say faint kilonova candidates, I think you could only try for the first night. Try to get some images for the first night. There is something you can do also if you think that, okay, my time is over, I think I can't observe or detect anything now, is to help the other users. You can give advice if people are posting images on Slack, asking for advice. Of course, you can discuss with people on Slack. You can also try to check the TNS, so transient name server web pages. So we will provide in the Slack alerts a link to the TNS server where you could check whether another professional team has made, for example, spectroscopic observation of this candidate and has classified it, for example, as a supernova type 1a. It would help people to say, oh, this candidate is actually a type 1a. I just checked it on the TNS server, and that's all. This is usually what I'm doing right now for the Kilonova FINK Slack channel we have in the professional Grandma Slack. I usually check each time we have a new alert. I usually check the TNS web pages to see if another team has reported something. So interact on Slack, and if you have no telescope available at all now or for the training, don't hesitate to also help people discuss, try to check the TNS server pages, try to check the Gaia alert pages. So all these pages, so TNS, Gaia, etc., are available on the dashboard of the FINK on the FINK web pages, where we provide the link in the Slack alerts. So don't hesitate if you think you can't observe to also give advice or just discuss about things and help people to understand what we are observing right now. And maybe there are other cases, but if you have access to spectroscopic telescope, so if you can make spectroscopic observations, feel free to make it. It's always useful. It's to classify transient to have spectroscopic observations. I don't know if some of you have access to this kind of instrument or facilities, but this is it could be interesting also, of course.
Yeah, merci Damien. So I see there is a lot of message on the chat, and I would like to thank Alain and Damien and other maybe probably to answer to your question. Okay, so you have made your decision. Yay, I will observe, and you have observed, and as said Damien, it's raining, so just like don't say, oh no, I need to wake up like 3 times to do my, to observe, because Damien said, no, just be okay. It's okay, and just try your best. But imagine that you have an image and you want that we have a look, and maybe we can, take it for scientific exploitation. So the goal is also to give the image right to the chroma collaboration. And so when we will have our website, here it will be super easy. And for the moment, we are still like really finishing the website. So we propose an alternative today to really start the campaign is to upload your image on the OnCloud. This is like a Google Drive. And for that, you need to register on the Gamma OnCloud. And then, so I give you the form. You need really to put project Gamma, okay? Otherwise, your name is lost, and I cannot, attach you and confirm you into the project. So you make this registration form. Here is a link, and then you say, "Hey, Sarah, I am registered, and I can give you the grant to the, to the repo." Okay, so imagine that you're registered now. So there will be a repository that we will create, and then you can just like, oh, then you have your fingers front. Anyway, you can just upload your FITS file. So we want FITS file with this kind of naming. Okay, don't put like my image, because otherwise it will be a mess. And for the kind of header or keyword, so try to accelerate a bit the talk, but you will have, you can have this header keyword. Of course, it is non-mandatory, but all the things that you practice now will be gaining time for having good practice already now. Okay, so some slide 21. I just would like to say, yes, if you cannot observe for any reason on your telescopes, or you don't have telescopes, or you want to help in another way, Homa and Kilonova-catcher, this is the TNS really help to know if we are going to be so excited because it can be really a Kilonova or not, is to look and be vetting the event, like looking at TNS, as Damien is doing our super survey what is going on in TNS. And last time for grandma, say, okay, guys, you cannot be a Kilonova because it has been categorized by other, as you see in TNS, as super type 1. So you can do similar to Damien, like just give a message as an answer to the Slack and say, yeah, it's also not a Kilonova file, but maybe next time. So take home message, maybe I will repeat myself. So this is ready for training during the summer that we start, in June, yeah, June right now, what do you know? Okay, right now, that it is providing by both FINK collaboration and Gamma collaboration using the ZTF alert stream, so things from ZTF, that for the moment, there is only one day that you can receive alert or not from us. This is from Friday from 2 UTC to 13 UTC on two different Slack channels. We are not going to send them, for example, by email. And sometimes, giving what the Sky will give, sometimes maybe 1 week there will be no candidate. Okay, so if this Friday you say, oh no, but Sarah has told that there will be some candidate, but there is no candidate, this is because there is, nothing that was might like a Kilonova. So this is what I said. Then we have a countdown of 72 hours post alert to perform the thing. So it's mostly during your weekend. I hope it is fine for you. And then you're invited to upload your image on the Grammar on Code server that I talked about. And if you cannot observe, this is fine. You can participate with others on the Slack discussion and look at TNS webpage. And so, as I said, we will try our best to analyze your data. We have already some tools to analyze it, but we need to do it, by hand. For the moment, we try to be more robust for and give you feedback on your data, but please don't ask us to give feedback just the day after it. We need some time to process.